This video is going to have a look at the Haber process. The main aim of the Haber process is to obtain and produce ammonia. So, looking back on the previous video, ammonia is used for fertilizers. Now, nitrogen is obtained from distillation of air, and hydrogen is obtained from fuels. Now what will happen is when you react those together, it will form ammonia. But unfortunately, at the same time, the backward reaction is happening and it's turning back into nitrogen and hydrogen. So the Haber process is all about finding out and using the best conditions to get as much ammonia as possible. Now, normally, if you think back to the stuff that you did in Year 9 and in the additional science, if you wanted to increase the production of something, you would increase the temperature, the concentration and the surface area. Now, because we're dealing with gases, you can't increase the surface area, so what we can do is increase the temperature and the pressure. However, you also have to take into account that this is a reversible reaction. So in this case, the forward reaction is exothermic and the backward reaction is endothermic. Now, in a reversible reaction, if you raise the temperature, the endothermic reaction will be favoured to use up the heat. And then if you reduce the temperature, the exothermic reaction will be favoured to give out more heat. So as you can see from this, by raising the temperature, the endothermic reaction is going to be favoured. So we're actually going to be increasing the amount of nitrogen and hydrogen produced. So by reducing the temperature, the exothermic reaction, the forward one which we want, is the one that is favoured. However, the issue with that is by reducing the heat, the reaction is still going to go slower because the particles are moving at a slower rate. Therefore, you need to find a balance between it favouring the endothermic reaction and producing more nitrogen and hydrogen, and the reaction occurring fast enough. The next thing to look at is pressure. If you raise the pressure, it will favour the reaction which produces the least volume. And if you lower the pressure, it will favour the reaction which produces more volume. So in this example, by increasing the pressure, it actually favours the forward reaction. So we want as much pressure as possible. The issue we've got though is if you increase the pressure more and more and more, it becomes more and more expensive because you need more and more powerful containers to withstand the pressure. So again, a compromise needs to be met. This is where the Haber process comes in. So to begin with, hydrogen and nitrogen is pumped in to a reactor vessel. The conditions set are 450 degrees C, because it's a lot better to produce 10% of ammonia really quickly than it is to produce 60% over a long period of time. So we go for a higher temperature, and then 200 atmospheres pressure, again which is a compromise between cost and high pressure. In the reactor vessel, the reaction occurs, and you'll have both the forward and backward reaction occurring. So what then happens is the gases that have been reacted will be passed through here into a condenser. Now, ammonia will condense a lot sooner than hydrogen and nitrogen, so the ammonia turns into a liquid. This allows any unreacted nitrogen and hydrogen to come back up and be re-reacted. So it goes back through, and this process continues until all of the nitrogen and hydrogen has been converted into ammonia. The only other thing that is used to speed it up is a catalyst. Which helps to speed up the rate of reaction. So I'll go through that one more time. Hydrogen and nitrogen are passed into a reactor vessel at 450 degrees, 200 atmosphere and a catalyst. A reaction occurs. As it comes through, it passes into a condenser. The fully reacted ammonia is condensed into a liquid, and the unreacted nitrogen and hydrogen is passed back round to continue the reaction until all of it is done.